So we are working in problem number 10. Problem number 10 says, in 1995, the size of a typical personal computer processor was 3 8/10 centimeters by 2 9/10 centimeters. In 2009, a smartphone processor can be as small as 1 1/10 centimeters times 8/10 of a centimeter. How much larger is the 1995 processor than the one found in today's phones? Now, notice this is a little dated because this information was from 2009. I am sure that they are much smaller now. But let's use the information that we have here. First, we need to have a sentence. So notice that my sentence is, the processor in today's phone is blank larger, larger. And we know that that is going to be in square centimeters. So right now, we need to think about those hidden questions. So we need to know what the area of the 1995 processor is, what the area of the 2009 processor, because they're talking about the size. And as soon as they give you two dimensions, they give you two dimensions right there, 3 8/10 and 2 9/10. You're thinking rectangles, because rectangles are a two-dimensional figure and they're giving us two sides to it. So we need to find the area of the 1995 processor and the area of the 2009 processor. So when we go through and we do that, the 1995 processor. Remember that for area, we need to multiply the length times the width. So the area is length times width. So for the 1995 processor, we're going to take 3 8/10 and we're going to multiply it by 2 9/10. So let's go through and remember, we're going to multiply this 2-digit by 2-digit as if it were whole numbers, and we will look at the end and decide where to place our decimal point. If I were to estimate here, I would say that this is about 4 and this is about 3. I'm going to get an answer that's about 12. So let's go through and let's multiply. Carry the 7, 9 times 7, 9 times 3 is 27, plus 7 will give me 34. Now I'm going to put my 0 placeholder. 2 times 8 is 16. 2 times 3 is 6, plus the 1 carried is 7. So right now I have the digits 1, 1, 0, 2. I have to think about where to place my decimal point. My estimation would tell me to place it here in between the 1 and the 0. If I look and I think about tenths times tenths, I know that I need to have hundreds, and that would give me hundreds place value. I can look and I can say that I have 1 place in my first factor plus 1 place in my second factor. I have 1 plus 1, I need to have 2. So no matter which way I'm thinking about it, I know that I have 11 2/100 square centimeters, because remember, we're figuring out area, we're counting the squares. So now we need to find the area of the 2009 processor by doing the same thing. We need to multiply those two measurements, the length, which is 1 1/10 centimeter, times 8/10 centimeter. Notice I didn't put that 0 that's in the ones place. It's a 0 I don't need. I don't need to worry about that in my multiplication problem. I'm going to set it up like a regular whole number multiplication problem. It's a coincidence that my decimals line up, but they don't have to. I'm going to go through and I'm going to multiply, and I get 8 and 8. So now I need to think about where my decimal point needs to go. If I think about an estimate, I know that I have about 1 times about 1, I'm going to get an answer that's about 1. If I think about my places, I have tenths times tenths, I need to have hundredths. If I look and I say I have 1 place to the right in my first factor, 1 place to the right in my second factor, I need to have 1 plus 1, I need to have 2 places in my answer. All of these will bring me to putting my decimal point before that first 8, so that I have hundredths, I have 88 hundredths. I need to label that as square centimeters. And now I need to find that difference. I need to do a subtraction. So I'm going to take my larger one and I'm going to subtract my smaller one to find the difference between that 1995 processor and the 2009 processor. So I need to subtract, and this is where the decimal points, lining them up, is very important. So I'm going to borrow, and I get 12 minus 8 is 4, 9 minus 8 is 1, bring down my decimal point, and I get 10. And we have to remember that because we found the area, we have 10 and 1400 square centimeters. Because we were comparing the size, and we measure area of a rectangle using square units, square centimeters, square inches, square feet. So we found the difference as being 10 and 14 square centimeters, 10 and 14 square centimeters.